Thank you. Yeah, I just get my laptop connected to the power so it doesn't turn off while I'm speaking and stuff like that. The QR code is there for you to scan if you want to follow the talk on your own device or follow the slides on your own device. There we go. Oh, does it work? That looks better. All right. Somebody wanted to give me a clicker. But no worries. Yeah, hello. Welcome to my talk on database abstraction. The title is actually pretty generic, but of course it's a trap. It's the Doctrine talk of the day, so I'm mostly will be talking about the Doctrine libraries. So first of all, who is this guy talking here? My name is Alexander. This is my GitHub profile. On GitHub you find me as Derabus. So if maybe you've encountered me on one of the projects I'm involved in already, and maybe you like what I'm doing. So many people are not aware, but this GitHub profile actually has a sponsor button. So just leaving this here. Tell your boss. So I work as a freelancer in my projects, and I usually work with Symfony and Doctrine there. Yeah, I believe in open source. I use open source libraries for my daily work, so I also contribute back to those libraries. Sometimes I annoy the maintainers of those libraries that much that they hand over extra keys to the repository to me. So this is how I became a co-developer of the Symfony project and also of the Doctrine project. In my projects, I like code bases that have aged like a good whiskey. If I'm not developing in my paid time and in my free time, I also maintain 4 long-term support releases at home. So yeah, that's me. And today I will be talking about the Doctrine project, or libraries of the Doctrine project. So what is Doctrine? Doctrine is a project that develops a couple of libraries with the main focus on database storage and object mapping. So the most famous one is probably the Doctrine ORM, which allows you to map the content of a relational database to objects. Here, for instance, we have like a table of persons, and we can have a person class in our PHP code, and the library takes care of mapping that content to this particular class. So who of you is using the Doctrine ORM actually? Okay, so about half of the room. Who likes using it? Okay. That's a few less hands, but yeah, maybe I can convince you to come back or to like it. Actually, my goal is to convince you to use the ORM by using it less. The libraries I'm talking about today is the ORM on the one hand side, and the other one is the DBAL, which is the database abstraction layer, which is below the ORM. So if you're just using the ORM by now, you might have encountered it because you can ask the entity manager for the database connection, and what you actually get is the connection of the database abstraction layer of the DBAL. And below the DBAL, we have the native extension for your favorite database, which is usually a C extension compiled into PHP or compiled as a PHP module. So what does the ORM do for us? It allows us to map a PHP class to a PHP table. We configure this through a metadata mapping. So we annotate on this class that this class is used as an entity, that it's being mapped to a table named persons, and then it has a couple of properties that are mapped to columns in the database. As we can see here, I don't have to really specify the type anymore. It used to be that I had to say that this is an integer in the database, but nowadays it's been detected automatically because PHP has advanced and gave us the magic of typed properties. So if there is an integer typed property, then I don't have to explicitly say that it is an integer in the database as well. I can still do this if I have some custom types, but for the most common ones, I don't have to do this anymore. I can also optionally say how this is then, how the column is called, because it could be that it's a different name than the property. I can set some options on it, like here for the strings, I can say how the maximum length is in the database. Databases usually want to know what's the maximum length of a string. For very good reasons. Yeah, but that's about it. I can configure how a class is being mapped to a database table. I can do this through a XML configuration file if I don't like annotations, but I personally prefer annotations, and it's also for code examples on slides. It's easier to follow if the piece of configuration is directly annotated to the piece of code that it configures. But as I said, if you don't like annotations or attributes, then just use an XML file. It's still fine. What it then will create is it will create such a table here. So I don't have to worry about how my favorite database wants this table to be created. Or maybe I have an entity model that should be mapped to different databases. Maybe I want to use SQLite for tests and MySQL in production, or maybe I develop a piece of software that can be deployed on MySQL and Postgres and DB2 or whatever. Then this is really handy because I define my metadata on the classes that I want to map, and the ORM or the DBAL in the background are taking care of emitting the right syntax for my database that I'm currently using. So now that I've mapped it, what can I do with it? I can persist new data in the database. So I just create a new instance of my entity object. I populate all the properties that I want to populate, and then I hand this object over to the entity manager. I say, hey, this is a new object. Please be aware of this. And then the entity manager will recognize or remember this object. And then I say, flush everything that you have remembered to the database. And then my new object will become a database record. And in this particular case, because I have told through the metadata mapping that the ID property should be mapped to an auto-increment column, I also get the ID is populated after flush, so I can query the newly generated ID from the object. So what it does in the background, again, is it will generate this insert query so that my object is actually being persisted in the database. So it's kind of like SQL for people who hate SQL, right? I don't have to worry anymore how to type this SQL or how this maps to SQL. It's just being written for me and it's being persisted for me. I don't have to think about it anymore. So this is a good thing, right? Right? Maybe. Let's see. I can, of course, also retrieve objects from the database. So once I have persisted a person in the database and I know its ID, then I can query it. So I can just tell the entity manager I want the person with the ID 1. Then I will get a person object or will get null if this is not found in the database. And then, what happens in the background again is that this piece of SQL is being generated. So all the properties that my class maps are being selected from the database explicitly from the table that belongs to my object, and here we see the primary key lookup. So pretty straightforward, but again, I don't have to write that SQL anymore. It happens in the background. What's next? Of course, I can also update content. So what we see here is we select a person from the database. We change a property here. I think in this case, I've killed William Shatner. I hope this ages well. What happens again is the person is being selected. That's what we've seen in the previous slide. And afterwards, we update this one property that has changed. So what's happening here under the hood? As you can see here, I'm just telling the entity manager to flush. I'm not telling the entity manager to flush this particular entity. I'm just telling it to flush all the changes. So what happens is that the entity manager keeps track of all the objects that it knows of, that it either knows because I told that this is a new object, please remember this through the persist method that we saw earlier, or it remembers this object because I have selected it from the database. Either way, the entity manager knows about all of these objects. It tracks them, and if I call the flush method, it iterates over all these objects and tries to find changes on them, right? This is something that we have to keep in mind because this is, you can imagine if I do this for a lot of objects, this can become a problem. What else can I do? I can also write something like SQL against my object model. So we call this language DQL, or Doctrine Query Language. So I'm writing a select query, not against the person table, but against the person entity class. And I'm not using the column names here because, as we remembered from the earlier slide, the column name is called alive only, but I'm using the actual properties of the person class here. And I'm also using PHP types because true and false is something that my database, unless I'm using Postgres, is not aware of. So my database probably doesn't know what a Boolean is. Yeah, what I then get is, again, I get this this nice little select query out of this. So this is being compiled into SQL. The DQL is being compiled into SQL and then being executed. You don't have to be afraid that this compile step is too expensive, because if you are running the same DQL query multiple times, then we will have a cache that knows if this DQL, this particular piece of DQL, is being compiled to this SQL code. So if you execute it a second time, then you will probably get the SQL statement from the cache. So the actually compilation should amount to 0 here. What else can we do? We can also define associations, like relations between our objects. So after all, we are mapping to a relational database, and in a relational database, we don't just have a set of isolated tables, but we have something that is called foreign keys. So a table can reference the primary key of another table through such a foreign key. And we can map this to our Doctrine entities as well. So I can say that I have a collection of actors that star in a certain movie. This collection of actors is then mapped to my person entity, and I have a many-to-many association. That means a person can star in multiple movies, and one movie can obviously have multiple actors that star in it, right? So this is then being hydrated to such a what we call a collection, and this is what is important to know about this is if I then would select all the movies from the database, I will get in each movie I will get a collection of actors, but this collection is actually not populated. It's a so-called lazy collection. So I just know that there's a collection of actors on this movie, but as soon as I start iterating over this collection of actors, the actual list of actors would be queried from the database. This is, of course, also something, we see this on the next slide, this is something that we need to keep in mind, because if I do something like this in a for each loop, so I'm selecting multiple movies from the database, and for each movie I'm looping over the actors, and we're working with lazy collections here, then I will get not one query against the database, but 1 plus the number of movies that I've selected. So it's 1 plus n. It's a typical 1 plus n problem that is hidden from me if I don't look into this, right? So I might think I'm only sending one query, but in fact I'm sending n plus n1 queries. There are ways to mitigate this. So while selecting it, I could do an explicit join so that the collection is always being populated and then everything is being fetched through one query. I can also configure this association as eager, and this means whenever I select a movie, I always want all actors to be selected along with it, which also reduces the number of queries, but this is something I need to know. So where do I believe does the ORM really shine? So what's the use case? Why do I want the ORM? So first of all, what I get is a type-safe data access. So usually when I query stuff from a database, what I get is a collection of strings, right? So sometimes, or the database drivers have become a bit more smart about this, so integers are actually being cast to integers and floats are actually being cast to floats, but in most cases that's about it. So if I select a date from the database, I will get a string with a formatted date in it, and the date format depends on the personal preferences of the people who built that database. So a date string from MySQL looks different than a date string that I get from Oracle, for instance. And in Oracle, it even depends on the configuration or on local settings. So this is not fun, right? So, but when I would select such a date through the ORM, so that the date is being hydrated into an entity, I will actually get a datetime or datetime immutable object. Depends on my preference what I want. So I actually get a date, and I don't have to care about how this strange string that I would get from the database is being mapped to a datetime object. I believe that it is really helpful for CRUD operations. Like I want to create a new record in the database. If I see that how the object is being populated with data, this is really readable. I don't have to care how this data is being mapped to the database. It's being done for me, right? Or just retrieve a single object from the database, retrieve a list of objects from the database, delete a record from the database. This is all those easy operations. They are pretty straightforward with the ORM. I think it's also very helpful if I work with any kind of rapid application development tool, like a forms library, for instance, Symfony Forms. I can build a form that maps an entity to a HTML form and make database content editable in a matter of minutes. Yeah, it's pretty fast to get to this point that I just create a new person in the database through a form in the browser. It's also pretty straightforward to expose a database table through a RESTful API. For for instance, with API Platform, which is a API framework built on Symfony. So I can just simply tell API Platform, this is my entity model, and on this endpoint, I want my persons table to be exposed, and then it simply works. Right? It's just a matter of minutes. The API Platform can leverage the ORM for querying the database for this API. Yeah, and everything's fine, right? Also, since CRUD operations are being made easy, also the API for modifying database content or deleting database content is also pretty straightforward with API Platform. And then there's also those admin generators. So I told you that it's easy to generate a form that makes database content editable. If I take this one step further, there are tools like EasyAdmin that can do this like for my whole database. And I just have to configure a couple of things, and then I have forms for all the tables in my database. And somebody without knowledge of how databases work or how PHP works could like edit my database content. So this makes like prototyping applications pretty fast. That makes like bootstrapping a new application pretty fast. And as soon as I have more strong opinions on how the API should look like and how an administrative backend should look like, I can still push back those red libraries and build my own stuff over it. And this is absolutely fine, but just to get things up and running at first, this is really great. And also, those entity models are portable along databases. And as I've said earlier, if I want to build an entity model that I can deploy in SQLite for having fast in-memory tests, and but I probably don't want to use SQLite in production, so I use MySQL or maybe even a different database in a production environment, then I can do this with the ORM. This does not necessarily have to be a requirement that I have for my own application. So most applications that I work with don't have that requirement that they should work on MySQL, on Oracle, on DB2, on you name it. But if you plug in any third-party libraries, like the ones that I've talked about earlier, then this circumstance that those libraries don't have to worry anymore about what database I'm actually using is really a unique selling point for the ORM. So, but now I've told you why the ORM is really great, or I believe the ORM is really great. So, but where isn't it great, right? There must be downsides to this. And here's one particular example where the ORM, or it's a typical pitfall that people who start using the ORM typically fall in. So anybody who's maybe more experienced with the ORM, or anybody who listened carefully to where you have to take care of what I said earlier, does anybody recognize where I've hidden the trap in this piece of code? Yeah. No, that's exactly not what's happening, because I'm flushing at the end, right? I'm flashing at the end, so I have one big chunk of SQL that's being sent to the database in the end for how many records? We don't know. So persons CSV could be 10 records, then it's fine, probably. Could be like 200 records, also fine, probably. This could be 2 terabytes large, this file. Then it's probably not fine, because what then happens is I'm loading 2 terabytes of data into my memory, but it probably won't fit on today's computers, at least. And then I'm flushing everything at the end. This probably won't work, right? So unless I'm pretty sure that this person CSV is really small, this piece of code has a problem. So the usual way to mitigate this is something like this. So every 100 records that I've read, I'm explicitly flushing. And very important, I'm also clearing the entity manager. So I'm telling the entity manager, just forget about everything that you've seen so far, because all the content that you've loaded or that you've been made aware of so far is not important anymore. Yeah, just clear everything out. Because if I wouldn't do this, it would still remember all the records that I've persisted previously. Because I could have, later on, I could have changed properties on those objects. And this could be a problem, right? This is why I'm clearing here, and I'm also clearing, obviously, at the end. So kind of, I've solved the problem now. Batch operation is fast again, and it's not leaking memory and everything, so we're good. But the problem that I want to get here at is that if I want to keep an application that uses the ORM extensively, if I want to keep it fast and with a low memory profile, then I need to know what it's doing under the hood. I cannot just use it as a black box. I need to know which operation triggers what operation on the database and which operation triggers what in the memory management of the ORM. And I might actually need additional tooling for that. So one easy additional tool is, for instance, the Symfony profiler, which just tells me which queries are being sent during a request, which is very helpful for discovering this n+1 problem that I've talked earlier about. But when it comes to memory usage and everything, then I probably need a real profiler that, like Blackfire or Typeways, something that looks at everything that my PHP application does somewhat from the outside. So this makes the whole thing, or the whole usage of the ORM a bit more complicated than it looked like in the beginning, right? And there are probably also certain operations where the ORM really gets in my way. This is what I would call the 80-20 problem. This is the 80-20 problem is something that I think occurs in multiple ways during software development, but it applies in particular to the ORM. The ORM might work well for like 80% of the use cases that I have in my application, and for the rest of the use cases that I have, it can really be a pain in the ass. It could get in my way. Also, do I need everything that the ORM does for me? So I've said earlier, this full database portability that it provides for me, it's helpful if I integrate third-party libraries, but for my own application code, when do I actually need it? So I've worked on very few applications that actually target multiple databases. Usually the applications I work on decided for one database, like MySQL in the beginning, and they are using MySQL now, and they probably will use MySQL until they are sunset, right? So they are stuck to MySQL, and it's probably fine. So what is the consequence of that? Many projects that I've seen, developers build the stack exactly like this. So they have the application sitting on top of the ORM. And because the ORM is in there, and the ORM is their way of accessing their persistence layer, they're accessing their database, the ORM has to be used for everything, period. It's there, it has to be used. The ORM then uses the DBAL uses native extension, but this is all stuff that I don't care about because I use the database through the ORM exclusively. And then they notice, well, but the application gets slow, and I cannot control this anymore. So the ORM must be the problem. So what they then fall back to is this. So the ORM is being thrown out because it's just in my way. I'm using the DBAL directly for querying the database. The thing is, they still have that problem that in many cases they want to map database content to actual PHP objects, because this is how we usually want to work in our applications. Maybe for those batch operations that I've shown earlier, where I just read a CSV file and just write it to the database. Maybe there the whole object thing is not that important for me, but just for developing my business logic, it is probably helpful that I have actually object representations of my database. So while those people think they've built this, they actually built this because they've re-implemented all this stuff that they liked from the ORM. They've built their own mapping logic that maps database content to objects. And I would strongly recommend to not do this, because mapping database content to objects, this is a problem that has been solved already. If you don't like the Doctrine ORM, please use any other library that does similar things, but don't reinvent this yourself unless you want to do this once for educational purposes. Right? I can really recommend to write your own ORM once in a pet project just to see how an ORM works. It's just like writing a web framework. Do this once in a pet project just to see how such a framework works. But please, don't deploy your own web framework or your own ORM to production. Or don't implement it in your professional projects. So what I would recommend instead is building a stack like this. So use the ORM when it's helpful to use it, or when you consider it helpful. But in the cases where it gets in your way, it's fine to bypass it. And we encourage you to do this because the entity manager exposes a method called getConnection that gives you the database connection where you can send plain SQL to the database. This is fine. There's no shame in that. And you don't have to use the ORM for every operation just because it's there. And also, there might be cases where even the DBAL is too abstract for you. You need a very specific feature of the native database extension from the native database extension for your favorite database. And because you need to access a feature that the DBAL doesn't have an abstraction layer for, then please go ahead, go one level deeper, and use the native extension for that, for those particular cases. And again, we encourage you to do that because there is a get native connection on the DBAL connection that gives you the MySQLi object, that gives you the SQL Server resource, that gives you, well, even the PDO object if you want to use PDO. So it's all there. Just use the level of abstraction that is, or that you find helpful for your particular use case. So now that we've talked about the ORM and where it's helpful and where it's not helpful, I'd like to tell you a bit more about the layer underneath, the database abstraction layer, the DBAL, and talk about what it can actually do for you. So the DBAL, as I said, is a bit more low level. It allows you to directly interact with the database by sending plain SQL statements. And it provides a unified interface for you. So you have a single connection class, you have a single class for prepared statements and for results, and this class is being used no matter what the database underneath is actually like. So it's the same class for MySQL, for Postgres, everything. It's the same connection class. And if you have ever worked with a native PHP extension for a database, or you have even switched from MySQL to Postgres and worked with both database extensions directly, then you probably know that all of those native database extensions for PHP are ugly. They are just all ugly. I don't want to touch them. They have been developed probably during PHP 3 or PHP 4 or PHP 5 times, and they've somewhat look like how PHP looked like back then, and they cannot be changed because this would break too many applications out there. Then they have all very strong opinions on how the methods are being called and how you write prepared statements. All of this is different among the different database extensions. So normalizing this was something that the ORM really needed, and it is, I think also very helpful to be used, because I like working with those interfaces really more than working directly with the native extensions. But apart from that, what does it also provide? It provides a schema management, so I can I have separate slides for that, right? So this is the connection wrapper that I've talked earlier about. We have the connection class. It's, as I said, the same interface for all databases, and yeah, we get a result. You can iterate over this. This fetch method, for instance, is also something that static analyzers like, because usually the fetch methods of the native database extensions have they usually have like a fetch function that you hand over a connection handle, and then you hand over some obscure parameter that tells you if you prefer to have your results with numeric keys, or if you want to have them with associative keys. You get what I'm saying. Yeah, so with this method, you explicitly say, well, if this is being called, I get an array with string keys where the keys are the column names that I've selected. Yeah, so what else do I get? I get a unified interface for prepared statements. So each database has somewhat a different opinion on how parameters should be formatted inside of SQL strings. Some allow parameters to be named. Some extensions only want parameters to be ordered. This is all being normalized, so if I prepare such a statement, the DBAL would normalize this to the actual syntax that your favorite database wants to have for prepared statements. And if your favorite database doesn't support named statements, it will emulate them for you. So yeah, this is being done in the background, which I also find yeah, pretty nice. What else does it do? It has a type abstraction. So mapping database types to PHP types is obviously a complex task. It's obviously something that the ORM needs. So the DBAL provides it for the ORM, and you can use it yourself as well. This is basically a bit more low level than the ORM does it, because yeah, here I can say that when I'm using prepared statements, I can say that, for instance, the isAlive is a Boolean, and yeah, then I get the particular type, and I tell this type to convert it to the value that the database would expect. So this is for instance in MySQL, this would be a 1 or a 0. In Postgres, it would be a T or an F. So each database wants to have their booleans differently. So this is very nice to have an abstraction for this. The same goes for dates, for instance. I've said this earlier. It would be nice if I could use an actual datetime object in a prepared statement, and with this I can. So I'm just giving I don't have an example for this on the slides, but I can just hand over a datetime object, can tell the DBAL that this is a datetime, and then it will convert this for me into the string format that my database expects. Yeah, and it also goes yeah, this is for inserting. This was for selecting, actually, right? Yeah. So it goes both ways. It goes for inserting and it goes for it goes for selecting and it goes for inserting as well. Sorry. Right. So what else does it do? It also has a schema management. So I can declare my schema as an object graph. I can say I have a schema, I have those tables in there, those tables should have those columns should have the following types and the following settings. And then I can tell the schema manager to deploy this to the database. This is especially helpful when you are dealing with different databases, because especially those DDL statements like the create table statement or the alter table statement, they are pretty much different in each SQL dialect. So creating a schema in a database agnostic way and then deploying it to the database is something that the ORM needed. If you need something as well, something like this as well, you can just leverage this. This is also being used under the hood by the Doctrine migrations library, if you know that. So if you're working with the ORM and you're changing your entity model, then you can ask the Doctrine migrations library, well, what's the difference between the database that that is deployed and my entity model, and it will generate SQL statements that would modify the database structure so that it matches your entity model again. And under the hood, this also uses this this schema management, because the schema management is also able to create a diff between two schema objects. So you can read a schema object from the current database. Sorry. Does somebody have a glass of water or something? I don't have water here, right? Thank you. Talking too much. And then, you can diff those two objects, and you will get a couple of create table statements, alter table statements that will modify the one schema so it matches the other. Thank you very much. Something that we've added to the DBAL, kind of recently, a couple of years ago, was this middleware layer. So, sorry. We go to the query builder first. So, the next problem that you have when you're dealing with multiple databases is emitting the right select statement for your database. So maybe even the select statements differ between databases, and also constructing maybe a dynamic select query. So for instance, you have like a table in your web frontend, and you have multiple ways to drill down that table. That might be that depending on what parameters are being set by the user, you have to apply additional where conditions, or you have to join additional tables and stuff like that. And doing all of this through string concatenation can get difficult pretty soon. So this is why we have a query builder that allows you to build this query programmatically through a PHP API. And this also allows you to conditionally change a query. Now we get to the middleware layer. So what we've talked about previously, those three objects that you mostly interact with, they are also mirrored down here in the driver layer. So those are agnostic to all databases, and those are specific for your database extension. So, meaning I have such a connection class for MySQL I have such a connection class for MySQL through PDO. I have such a connection class for DB2, and so on, right? Those are all specific to your database. And what we've added in between is a so-called middleware layer that allows you to intercept all the calls that go from the wrapper layer to the driver layer. So they have the same interface as the driver layer, and they wrap all of those objects again. So why is this helpful? For instance, if you've seen the Symfony profiler previously, that shows you a log of all the SQL statements that have been sent to the database. This is being done by such a middleware layer, by the middleware layer. There's a piece of middleware that is being injected to the connection, and it just sniffs all the SQL statements that are being sent to the database by just intercepting the calls here. Also, where it could be helpful is if you have like somewhat dynamic connection settings. So I was in a project once where the database credentials were somewhat hidden, obscure in some kind of data source that where I had to load them from. Don't ask, but it was important that the password, the decrypted password, it was encrypted. The decrypted password is not like being written to disk or anything. So I've injected a piece of middleware that just wraps this driver class, and whenever a connection should be opened, it adds the actual database password to the set of connection settings. Also, where it's helpful is like sending some queries to the database whenever you connect to the database. For instance, in SQLite allows you to define your own functions that are then being run within your application. So you can register a PHP function as if it was a database function, and you have to do this by sending a statement to the SQLite driver. And since you have to do this every time you open a connection, such a middleware is like the perfect place to do this, so your application wouldn't know that this actually happens. Where we also are using this is for fixing result column casing. So there are databases out there that have an opinion on how the columns in results should be cased. For instance, Oracle believes that no matter how I name the columns in the result statements, they are all uppercase. Why? But yeah, okay, it's that way. So if you want to normalize this, you can inject a piece of middleware that just lowercases column names everywhere, and then no matter what database you're connecting to, the column names are all the same. So this is the kind of use cases where the middleware layer is really pretty amazing. And then again, the native extensions. So if the database abstraction layer is too abstract for you and you want to directly work on the native extensions, you can just query them from the connection. And those are the native extensions that we support. You can see there are all the dedicated extensions for the databases, like the MySQLi for MySQL and MariaDB. There's the PGSQL for Postgres, the SQL Server for SQL Server, the OCA8 for Oracle, SQLite 3 for SQLite, and DB2 for DB2. And for all of them except DB2, we also have PDO drivers. So if you still prefer using PDO to connect to your database, then you can do that, except when you're using DB2, because the DB2 driver is broken. Yeah, that's about the native extensions, and yeah, I've shown you the ORM and the DBAL, and next time you have to decide if you rather want to use the ORM or the DBAL. I want to give you a third choice, which is why not both. So this would be, first of all, the end of my talk usually, but since we have had new major releases recently, I've prepared 2 more slides to make everybody who is already using Doctrine a bit angry, because we have removed a lot of stuff. So the first thing is we have released Doctrine DBAL 4 recently. So the reason for those major releases was that we wanted to slim down both libraries. We are throwing out stuff that we think is not not useful anymore, or maybe wasn't ever useful, and we believe that it doesn't belong into those libraries. For DBAL, we, for instance, removed something like Doctrine cache. Doctrine cache was a caching library that the Doctrine project has built, and because back then there was no good abstraction for caching, right? Nowadays we have PSR6. Every framework has their own favorite PSR6 implementation. So why should we ship our own caches with our own interface? This is why we have migrated all Doctrine libraries to be able to talk to PSR6 caches. We've implemented wrappers that you can use a PSR6 cache as if it were a Doctrine cache. And in DBAL 4, we have removed the support for a Doctrine cache, so you have to use a PSR6 cache now. We have removed, for instance, the array and object types. Those types like wrote an array or an object into the database as serialized PHP string, as PHP serialized string. We believe that this is a generally bad idea. The APIs to build custom types are still there, so if you want to shoot yourself in the foot with writing serialized PHP strings into the database, you can still do that, but we felt that we shouldn't hand you the gun for this. We removed PHP 7 support because nowadays nobody should be using PHP 7 anymore, right? Right, good. Which also allows us to use enums in all APIs. So where we previously had like a set of constants that you could use to indicate what type a certain parameter is, this is everything is an enum now. Transactional methods are now void. This is like you start a transaction, you begin a transaction. It used to return a Boolean if that operation was successful or not, but it could also throw an exception if that is not successful, so you kind of had to check the return value and you had to catch the exception and why. So everything is void now, so if the operation fails, you get an exception always. We have removed the nested transactions without save points. What is this actually? So most databases don't support starting a transaction within a transaction. They have a system that is called save points. So if you are in a transaction, you can set a save point and then can roll back to that save point without rolling back the whole transaction. So this is a way how you can emulate nested transactions. If you disable the save points, the result would be if you had a nested transaction and rolled it back, nothing would happen because there was nothing to roll back to without rolling back everything, and this is yeah not what you have requested, right? So since this was not obvious, we have removed this possibility. We have removed the event system because for the most cases, the event system was redundant after the introduction of the middleware layer. So the event system is gone. The rest you can look this up. For the ORM, we have released ORM 3, which is the first major release since like, what was it, 12 years or something. So we really had a lot of stuff that we wanted to throw out there. Try to migrate to ORM 3. If you have problems with that, please give us feedback through our issue tracker. We know that this is probably a hard migration for you. Also, although we did everything that we could to prepare you for that by omitting deprecations. The things that we removed, for instance, was Doctrine annotations. You probably remember Doctrine annotations, which was like a way to annotate configuration through PHP doc blocks. Now we have attributes in PHP, so Doctrine annotations are not really needed anymore. If you have a large entity model that is being configured through Doctrine annotations, there's a tool called Rector, which is pretty good at rewriting those annotations to PHP attributes. So please use that tool. If it doesn't work for you, then give us feedback or give Rector feedback, because this was actually our motivation. The existence of this tool was the motivation that we removed Doctrine annotations. same here, we removed Doctrine cache, we removed PHP 7 support because DBAL also removed it. We removed the Doctrine common library because everything that was in there is not being used anymore. We removed the YAML configuration. So if you want to configure your metadata mapping, please use XML or use attributes. We removed, this is probably the part that is painful if you rely on this heavily. We removed partial flushes, partial clear, because this has not worked as people believed that it has worked, and it introduced a lot of complexity to the code base. We believe that there are better ways to do this, so it is gone now. If this creates a problem for you, please also talk back to us on the issue tracker. We can probably find a solution to that. So this was the anchor, and I would like to thank you for your attention. And yeah, if you find me on your favorite social network, you find me on GitHub as Derabus, and yeah, you can send me an email if you don't want to use social media to contact me. Thank you very much. So I think we have a few minutes for questions, so if you have any questions, please don't hesitate to ask them. One thing though, if the question is something like, if I do this, then I get an exception, this is probably something that is not good for a great audience or a large audience, so then please come directly to me, maybe I can help you.
So my question is that if we had a pre-existing database,
yes,
is it possible to reverse engineer the entity model from it?
Yeah, so we removed code generators. So what you can do is you can reverse engineer the schema, because the DBAL has this schema management, and you can ask the DBAL, give me the schema for this existing database. And then you can use that schema to write a code generator that writes entities for those tables. The reason why we are not providing a fully fledged code generator anymore was that it has never worked for anybody in exactly the way that they wanted it to work. So people used that generator. They saw that it doesn't quite generate the entities in the way they wanted it to, and then they wrote their own generator. So we thought maybe this is the best that we can do. We give you the tools to reverse engineer the schema and to actually generate the entities in the way that you want them to be in. Therefore, there you can write your own generator. Anybody else? Yes.
Yeah, thanks for the talk, really good. Doctrine cache, is that result set caching that's now using PSR6?
Yes, for instance. It is also it's also being used for caching metadata. It was used for caching the SQL that is being compiled out of the DQL, all of this. So Doctrine has the ORM and the DBAL has certain, but both libraries have certain needs to write to a cache occasionally, and they needed a backend for this, and they needed an abstraction for multiple backends, and this is why this Doctrine cache library was initially created. But since there is now a standard for caching, which is PSR6, and there are very good libraries for caching, for instance, Symfony Cache, we don't want to provide our own implementation of this anymore, because there are projects out there that do this better than we do, and we are just a small project with just a few developers, so we want to focus on the stuff that we are really good at. Yeah. Okay, then I think we're done. Thank you again, and yeah, enjoy the rest of the conference.